This is another example for motion along a straight line or one-dimensional motion. The question states that a car travels one-third of its total distance with a constant speed, 10 meters per second. Then the next one-third of the total distance is traveled at 20 meters per second. That's also a constant speed. Then the final one-third is traveled at a constant speed of 60 meters per second. The question is asking, find the average speed of the car for the entire motion. Okay, so let's try to break this problem up. So I'm going to draw a sketch. So the motion is along one dimension. Let's say, like usual, it's moving to the right hand side. So that is our positive direction. But you can see here we are dealing with distance, speed. So they are scalars. The direction actually does not matter. And even the question is asking for an average speed, which is a scalar quantity, just the magnitude. Anyways, let's assume that the entire distance traveled is d. So that's the total distance covered by this object. For the first part, for the first segment, that means you can see one-third of the total distance. So if distance is d, one-third of the distance, the first one-third, I can write it as d over 3. For this part, the constant speed is 10 meters per second. So I'm first trying to put all the information in a visual way so that it's easy for us to understand. Then the next one-third, somewhere here, so that is again d over 3, that's being traveled at a constant speed of 20 meters per second, like that. And then the final one-third is traveled at 60 meters per second. So let me erase this because it's in our way. So I'll say like this is like the positive direction. Like that. And then here the constant speed is 60 meters per second, and that's the final one-third of the motion. Now find the average speed. So let's use the definition for average speed. So average speed is distance, total distance divided by the total elapsed time, or one could say elapsed time. Elapsed time. So total distance is obvious, right? It's d. It's the distance here. Okay, d is the total distance. Now, how are we going to find the elapsed time? So for each one-third, since the constant speed is different for each one-third, we should be able to, we have to figure it out individually for a given segment. So let me define that these times, let's say that this time over here, it's T1, this is T2, and then this is T3. And my objective is to find T1 and T2 and T3, and then you can see I can substitute the total time in the denominator, T1 plus T2 plus T3, and then I would get the answer. So the objective here is, how do I find T1, T2 and T3? That's also relatively easy because we know speed is equal to distance over time, right? So here it's constant speed. So we know this expression. So from here you can see we can substitute for, we can solve for time. So time can be written as distance, I'll call it dist, divided by constant speed. So we get that expression from this general one, like that. So now I am going to apply that for each segment. So I can write T1 is equal to, what is the distance? D over 3. 1/3 of the total distance divided by that speed, which is 10. Similarly, to T2 is the same distance d over 3, but this time it's divided by 20. And then finally T3 is same distance, 1/3 of the total distance, divided by 60. So now I'm going to substitute these things in the expression, and we should be able to get the answer. So now we can get the answer. So I'm going to write down the average speed again. That is d over the sum of the times t1 plus t2 plus t3, and then from the previous derivation I can substitute for t1, t2, 3t. So d over t1 is d over 3 divided by 10. Then I have d over 3 divided by 20, and then we have d over 3 divided by 60. Okay, so you can see the d cancels out from the numerator and the denominator, and then we have 1 over, I have 1 over 30 plus 1 over 60 plus 1 over 180. And then I just need to simplify this. So I'll get a common denominator. So over here I'm going to take 180 as the common denominator, and then I'll get 6 here plus 3 over here, and then 1 over here. And then you can see I'll get 180 in the numerator because this term goes to the numerator, and over here I'll have 10. So the answer is 18 meters per second. So that's the average speed of the car when we consider it's the total distance traveled. So that for that distance, this is how you figure out the average speed of the car.